Good day, everyone. I am Jaey Trecia of Ellorimo, and my assigned topic to be discussed is all about computing the comparison of nominal and effective rates, which is the lesson 3 of Module 2. So here is our learning objective. It is to compute and compare the effective rates of the two compound interest rates. So before we proceed to the discussion, here are the definition of terms of the important words to clearly comprehend the aim of the topic. So the nominal interest rate, it refers to the interest rate before taking inflation into account. Nominal can also refer to the advertised or stated interest rate on a loan without taking into account any fees or compounding of interest. While an effective annual interest rate is the real return on a savings account or any interest paying investment with the effects of compounding over time are taken into account. It also reflects the real percentage rate owed in interest on a loan, a credit card, or any other debt. So we shall explore the comparison between the nominal rate and effective rate. As already mentioned, nominal interest rate is the stated annual interest on which the compound interest calculation is based. So the word nominal, meaning the name only, is appropriate because the nominal annual rate of interest is not numerically equal to the actual rate of interest realized over a full year. So on the other hand, effective interest rate is the equivalent annually compounded rate. So the standard practice of comparing nominal interest rates is to convert each rate to its effective rate. Since the effective interest rate is the equivalent annually compounded rate, the formula for the effective interest rate and the nominal interest rate may be derived by equating the future amount of both simple interest and compound interest. Hence, we do know that the future amount of both simple interest and compound interest are denoted into the letter F or the capital letter of F. Therefore, the formula in finding the future amount of simple interest is the principal multiplied to the quantity of 1 plus RT, and the formula in finding the future amount of the compound interest is the principal multiplied to the quantity of 1 plus I, which is the periodic interest rate, raised to the power of n, which is the number of periods. In this case of equivalence, we consider the formula in the left portion as the formula in finding the future amount of the simple interest, and the formula in the right portion as the formula in finding the future amount of the compound interest. Then we need to replace the I in the formula of the compound interest and n by GM and TM respectively. Then divide both sides by P to cancel out those principal value. Then since T is equals to 1 year, therefore RT in the simple interest formula will become R, and the TM in the compound interest formula will become M. Then subtract both sides by 1. Therefore, we come up to the formula of an effective rate as equals to the quantity of 1 plus J over M raised to the power of M minus 1. Hence, we end up with the formula R, or the effective rate formula with respect to nominal interest rate. Then to derive the nominal interest rate, or denoted as G, we are going to use the formula in effective rate. So again, the formula in finding the effective rate, we have the R is equal to the quantity of 1 plus J divided by M raised to the power of M minus 1. Add both sides by 1 to cancel out the negative 1 in the right portion, then extract the nth root on the both sides, then subtract both sides by 1, and multiply both sides by n. Therefore, we come up to the formula of the nominal interest rate as m to the quantity of the nth root 1 plus r minus 1. So here is an example. Find the effective rate of interest equivalent of 17% compounded bi-monthly. So based on the given problem, we have the given of nominal interest rate as 17% or equivalent of 0.17 in decimal, and our given number of conversion per year is 6 since it is compounded by monthly. So to solve this given problem, we have to use the formula in finding the effective rate of interest. So therefore, we have the formula of R is equals to the quantity of 1 plus J over M raised to the power of M minus 1. Then, supply the given numbers. We have 1 plus G is equals to 0.17 and M as 6. So 0.17 divided by 6 raised to the power of M, which is 6, then minus 1. Therefore, we need first to calculate the number in close to the quantity. Therefore, we have 0.17 divided by 6 is 0.02833333 plus 1 raised to the power of 6 is equals to 1.182506635 Then minus 1, we have 0.182506351. And then therefore, we have the decimal point. Rounding it, we have 0.1825 or 18.25%. Or rather, we have a conclusion of the 17% effective rate is equivalent to 18.25% compounded bi-monthly. So here is another example. What rate converted bi-monthly is equivalent to an effective rate of 11%? So, based to the given problem, we have the R, or the effective rate of 11%, or written in decimal form of 0.11, and we have the number of conversion per year as 6 since it is converted by monthly. So using the formula we derived a while ago, we have the formula in finding the nominal interest rate is J is equals to M multiplied to the quantity of the mth root 1 plus R minus 1. So therefore, supply the given numbers. We have the M as 6 and R as 0.11. So 6 multiplied to the 6th root of 1 plus 0.11, since R is 0.11, then minus 1. So we have to so we need to solve first the numbers written in a closed parenthesis. Then we have the 6th root of the 1.11 is 1.017545481. Then minus by 1, we have 0.017545481. Then that decimals could be multiplied to 6. Therefore, we have a nominal interest rate of 0.1053 or 10.53%. Therefore, as a conclusion, we have a nominal rate of 10.53% converted by monthly is equivalent to 11% effectively rate. So try to solve this exercise. So at what nominal rate compounded monthly will a principal yield an interest that is equivalent to an effective rate of 19.5%? So based on the given problem, we have an effective rate of 19.5%, or in a decimal form can be written of 0.195, and the number of conversion per year would be 12 since it is compounded monthly. So here is the possible solution, or the solution rather. With a given R of 19.5% or 0.195 and M of 12 as it is converted monthly, using the formula in finding the nominal interest rate, we have the J is equals to M multiplied to the quantity of M root 1 plus R minus 1. So therefore, we have the conclusion of the nominal rate of 17.95% compounded by monthly is equivalent to 19.5% of effective rate. And that's the end of my presentation. Hope every one of us learned from this video. And thank you. God bless us all.